All right, so for this lesson, you're going to need a graphing calculator. So preferably if you have your own TI-84 Plus calculator, you'll be using that. Otherwise, you can kind of switch back and forth between watching this video and using the calculator link that you can find on my Schoology page. So either of the two will work, but let's go ahead and start. So for this first one, we're trying to find, so we're using what we talked about before with the standard form of equation for some real world application. All right, so here we have the graph, and they give us the equation that shows the profit a company earns for selling headphones at different prices. What is the maximum profit the company can expect to earn? So the x-axis represents the selling price of the headphones, and the y-axis represents the profit, how much they can make in total with those various prices. So if they start out real cheap, they're not going to make a whole lot of profit, but the goal is to try to find that sweet point, which is right here, where they're going to they charge the most for what they can make as far as the biggest profit. We want to figure out what is that maximum profit they can expect to make. Now, when we look at that graph, we look at it, we could estimate what it'd be, but we don't want to estimate. We want to get an exact value. And so we're going to do this on our graphing calculator. So we're going to get out your graphing calculators. So you're going to be in a different screen probably. So when you turn it on, you might be in a regular calculator screen. So go to where it says y equals, and I already have our equation typed in here for us. So you're going to do the same thing on your own calculator. So you might want to just pause this video. Make sure a couple things though. Make sure where it says a negative, you use the negative button down here next to the enter button. Where it says minus, that's where you want to use the minus button between the plus and times buttons. So make sure that you use those correctly, because if you use it incorrectly, it's going to give you the wrong answer. Your x's, to access the x button, you're going to use right next to the alpha, the green button here. You're going to find where you have x, t, theta, and a bunch of other things listed. Click on that to get the x button, and your squared button is here next to the comma button. So that's where all your buttons are. So go ahead and type that in and play when you're ready to move on. All right, so you have that typed in. Now let's go to your window settings, because your standard window setting is not going to be the same as what we have in our graph. So if you look at the graph that's in your notes, I'll go back to it here. So the graph, the x-axis goes from 0 to 80. Our y-axis goes from 0 to 8,000. And then if you notice on your x-axis, we're counting by tens with these grid lines. So we want to have a scale of counting by tens on the x-axis. Might say, well, it's counting by 20s. Well, I'm going by the grid lines. The grid lines are going up by tens, and the y-axis, the grid lines are going up by 1,000s. So let's change our window settings to reflect that. So I'm going to have my x minimum to be 0. My x-axis is going to go up to 80, so from 0 to 80, and we're going to have a scale of counting by tens on the x-axis. On the y-axis, we can go from 0 on the y-axis as our lowest value. Our y maximum value will go up to 8,000, and the y scale, like we pointed out, is counting by 1,000s. Everything else you can leave the same. And now if you go to graph, we get the graph on our calculator. Now we want to figure out this maximum value, so do not hit the trace button. Do not use the trace button. Hit second trace, and that's going to give us this screen. And if you notice the fifth option here, you can just type in 5 on your keypad, or we can just arrow down and hit 5 and enter. Either way, this is going to find us the intersection. Now it doesn't really find us the intersection right off the bat, because we might have a bunch, oh, sorry, I didn't mean to find intersection. My bad, hold on a second. Do that again. I meant to say maximum value. We want to find the maximum value, which is option 4. All right, so hit enter. So again, it gives us these little cursor points. Now notice down here on the bottom of our screen, it says left bound. So we're going to set that cursor anywhere to the left of where that maximum value is going to be. Do not try to get it right on the maximum value. Just put it anywhere on the left. Hit enter. Now notice how it changed to say right bound. And this operating system even gives us this nice little region here. Not all calculators do that. But if we go to the right of our maximum point, anywhere to the right, hit enter. Now it says guess. Don't worry about that. Hit enter one more time. And now it moves that cursor in between the two lines that we saw, and those two lines disappear. We find our maximum value. Now, what are we looking for here? Let's go back and read the story problem. So it says, what is the maximum profit? The profit we get on the y-axis. So remember, the x-axis represents the selling price. So let me go back to our calculator. So this 35 represents the selling price. So the maximum price that we should sell our headphones for are $35. And then we can expect a maximum profit of $6,250. So our answer is not both those values. It's very important to understand that we're trying to answer the question. So the question is asking us what's the maximum profit. So it would be $6,250. Oops, it's a 0 here. So that'd be the maximum profit they would earn. All right, so I want you guys to try that whole process on your own with this next one. The next one represents a water balloon was thrown from a window. The height of the balloon in feet over time in seconds we modeled by that function. So here the x-axis represents the time in seconds. So notice we're going to have to change our window settings again here. And then you're going to find the maximum height in this case for the water balloon after it was thrown. Okay, so go ahead, pause the video, hit play when you're ready to check your answer. All right, so when you did that, you should have, again, changing your window settings and then going through the process of finding that maximum value. Should have gotten a maximum value of 450 feet. So after 5 seconds, the 5 you wouldn't use, but 450 would be the maximum height. That's what we're trying to find. All right, so in this situation, they're giving us a table of values, and we're going to have to create a graph based on those table of values, or come up with an equation, rather, for that table of values. So how do we do that? Well, over here on the right, we have all the steps that we need. So you want to focus on those. If you don't have my notes, you want to take a screenshot maybe, or take a picture of that and get that highlighted, get that in your notes. So the process is going to be this. We're first going to start with the stat button. Zoom out here, and let's go back to our calculator. So we have this stat button that's right next to our arrow pad here, or touch pad. So hit the stat button, and we're going to go to edit. The first option, first thing we see is edit. Hit enter. Now don't worry what I have over here on the right for L4 and L5. Let me just clear those out. So if you ever have a bunch of data that you need to clear out, put your cursor over the L5 and just go over to where it says clear and hit enter, and that'll make it all disappear. All right. So now what I want you to do is I want you to enter in the number from the table that we saw in your notes, where distance from 1 through 10, enter in all those, and then make sure you type these in correctly. These would be the height in meters, so make sure you get those typed in correctly. Go ahead and do that. So hit pause right now in your video and hit play when you're ready to check or go on to the next step. All right, so hopefully you got all those entered in. So the next step is we're going to put press the stat button again, but we're not going to hit edit. We're going to arrow over. So on your touchpad here, arrow over to the right where it says calculate, and we're going to choose option 5, quadratic regression is what that stands for. And hit enter, or you could just type in 5 on your keypad. I'm going to change this to L1. Sorry, I forgot to do that. Yours already says L1, L2, so you don't have to worry about what I'm doing right now. But then you go ahead. So right now your screen would look like mine, L1, L2. So just arrow down, or I'm sorry, enter down until you get down to the bottom where it says calculate. Hit enter one more time, and it gives you this screen. So we need to interpret what the screen means. They're telling us right here in the top what form the equation is that we're using, ax squared plus bx plus c. And they give us our values for a, b, and c. Now we'll round to the nearest hundredths place, which would be 2 numbers after the decimal. And we're going to write it, though, in this proper form. So don't just write down what a, b, and c is. That is wrong. We want to put this into the equation. So we put that in our equation. Let's go back to our notes. We'll round those. So again, we're going to round to the nearest hundredths place, so 2 numbers after the decimal. So we'd have negative 0.03 x squared plus 1.0, I think it was 66, but we'll round that to 0.07 times x plus 0.6, we'll round that to 7, so 0.67. So that's the equation. Now the follow-up is it says, what will be the height of the discus when it is 15 meters from Esteban? So the distance, the value for x represents the distance from Esteban, and the height is our answer that we get for y. So what we're going to do is we're going to put 15 in for x. All right, so what you're going to do is you're going to plug that in. So we can go back to our calculator. So you just plug this in exactly as you see it on your calculator. To get to a calculator screen, we just want to quit out of where we're at. So you can just do second and then mode to quit, and you can just type that in all on your screen. And I'll just tell you when you do that, get your answer of 9.97. And that's going to be the height in meters, so we'd say 9.97 meters. All right, I want you guys to do the same thing now for this next one. I want you to go through the same process and write down what your equation would be. Do not answer the question yet. This one's a little bit different. We're going to do that one together. So we'll get to that in just a second. But I want you to first find the equation for this set of data by going through the same process while you follow those 8 steps over here. So again, these 8 steps are really important. So go follow those steps and do that on your own. So hit pause and hit play when you're ready to check to see that you got the correct answer. All right, so let's see what you should have gotten. So our equation for this problem would be y equals negative 16 x squared plus 12x plus 10. All right, when does a football hit the ground? So to be able to find that, we're going to actually need to graph it, because think about what we would have here. So we have actually starting out at 10 seconds. So when it starts, it's starting at 10. After 0 seconds have gone by, it's starting from a height of 10 feet. So it's going to go up, and then it's going to hit the ground at some point. And so we want to figure out how long it's going to take for the ball to hit the ground. So that's a coordinate where x is some number and y is 0. So I would not put 0 in for x. I want to put 0 in for y, which then I have to do this algebraically, which we don't know how to do right now. So we're going to solve this graphically. So let's go to a calculator screen. So we're going to type in this equation. So I'm going to clear this out. So to clear this out, just hit clear, and it goes away. So I'm going to clear this old one out as well. All right, so I'm just going to type in the equation that we just got, negative 16, and then x squared plus 12x. Whoops. Oh my gosh. All right, I'm going to pause this and type this in. So you guys go ahead and type that in. So now I didn't have any problems. So now you should have your equation typed in. So now let's before we graph this though, we need to change our window settings, because we have these huge numbers in our window settings. So from the last ones, or actually I do. Yours might be a little bit different. But the distance, our table goes from 1 to 10. Now we might go further than 10 units. So I'm going to go from I'm looking at the previous example. Our table goes from 0 seconds to 1 second. So let's go from 0 to 5 seconds. Okay, I don't know. So we're just going to play around with this and guess. And our x scale will count by ones. So for my y minimum, we'll go from 0. From our table, we could see that it goes from 10 to almost 12 to 12, and then it goes back down again. So I'm not going to have to go any higher than 12. So I'll just put in a y maximum of 15. Again, we can count by 5s on the y-axis. So let's see what our graph looks like. All right, so we could see everything we need, because we're looking to see when does that ball hit the ground. So we're trying to figure out what is this value here. So to do that, we're going to go to second and trace. Don't actually trace your graph. We're going to go to second, trace. And what that's called, our x-intercept is called a 0. So I want to find out when does it hit the x-axis, or what is the 0 there. So hit 2. And right now I could see that my left bound, it has where x is 2. So I'm way far down than what I have to be. So I'm hitting my arrow to the left. There we go. So we're going to move that cursor somewhere to the left of that x-intercept. Hit enter, and now I'm going to move my arrow to the right of that, which would be below the line. Hit enter again. Now notice those two lines. My x-intercept, sure enough, is between these two. So I've got my x-intercept captured. Don't worry that it says guess. Hit enter one more time. It gives me my 0 now of 1.25. My y value, sure enough, is 0. So that means that it hits the ground after 1.25 seconds. So that would be your answer for that problem. All right, so that's it. So that's our application. So you guys are done. So good luck as you work on your assignment now.